MA089, chapter 5.6, division of monomials. Okay, let's consider this example. This is a fraction. This means x to the 6th power is divided by x to the 3rd power. The denominator is the divisor, right? Divisor. So the numerator is, x to the 6th power means multiply the variable x, the base x, 6 times. 1, 2, 3, 4, 5, 6 times. And then the denominator is x to the cube, x cubed. So x is multiplied 3 times. Then how do we simplify this? Okay, so if a fraction contains common factors in the numerator and denominator, then we can cancel out. So you can get rid of 1x from the top and bottom. And then also you can get rid of another x because that is the same factor, right? And then remove another x. So what we have is, so the denominator is now 1, right? 1. And then the numerator is x. There are 3 x's, right? 3 x's. 3 x's. That means x cubed over 1, which is x cubed, right? X cubed. So basically what we did is we removed, actually subtracted 3 x's from the numerator, because the numerator has, there are 6 x's, the bottom has 3 x's, so we can remove 3. So actually we can write it like this: x to the 6th power of x cubed, isn't it same as this one? We subtract the exponents, 6 minus 3. So that is equal to x cubed. Does it make sense? So in this case, we can subtract the exponents, subtract the exponents. So 6 minus 3, so that becomes x cubed. Okay, let's try more examples. Well, based on this, we can write a definition, rule for dividing exponential expressions. So we can say that, okay, let's say m and n are exponents, okay, the powers, exponents. Let's say positive integers, but actually it can be negative, doesn't matter. So m and n are numbers, and the base x is not equal to 0. Then this monomial division, the division of this monomial is equal to what? X to the m minus n. Or you can move m to the bottom, but we can do it later. Alright, so for example, like this. The numerator and the denominator has the same base c. Then that means there are 8 c's in the numerator, 5 c's in the denominator. So this is equivalent to what? Subtraction, subtracting the exponent. So 8 minus 5. So that is equal to c cubed. Okay. So this is the quotient of 2 exponential expressions with the same base, right? Same base. Then subtract the exponents. So if the bases are different, then you cannot subtract. So as long as the bases are the same, then you can subtract the exponents. Okay, then how about dividing the exponential form which have the same exponents? So this means x cubed means x is multiplied 3 times, and the divisor is also same, x times x times x. Then we can get rid of each x from the numerator and denominator, so it becomes 1 over 1, which is 1, right? Or by definition, what is the formula for this? Since the exponential forms have the same base, you can subtract 3 minus 3. That is equal to what? X to the 0 power, 0 power. Then what is the x to the 0 power? Isn't it same as 1? Because we got 1, right? 1. So x to 0 power has to be equal to 1, right? So we can say that, 0 power of a non-zero number, if the base is not 0, right? X is not 0, then x is raised to the 0 power, then the answer will be 1. Not 0, it's 1. This is very important. So 0 as an exponent. So if the base x is not equal to 0, then x to the 0 power is equal to 1. But what if the base is 0? 0 to the 0 power this is undefined. Okay, so the base has to be not equal to 0, non-zero. So what is 15 to the 0 power? Of course, it is 1, right? 1. So any non-zero expression to the 0 power is 1. So if the base is not 0, then the 0 power is 1. Okay, now let's try dividing an exponential form by an exponential form whose exponent, the power is larger. So for example, the exponent of the denominator is now greater than the power of the numerator. So the numerator has 3x's, right? X cubed means x is multiplied 3 times. But the denominator now has 5. Then how to simplify this? We will do the same thing. So get rid of each x from the numerator and denominator. So what we have is 1 over x times x. Then this is equal to 1 over x squared. All right, then let's use our formula, x cubed over x to the 5th power. So this is equal to x to the, what is the exponent? 3 minus 5. And 3 minus 5 is x to the negative 2. The exponent is negative 2. So does it mean that these two are same, right? Same. So we can have something like this, x to the negative 2 power. X, the power is negative 2. Then that is equivalent to x squared. Can you see the difference between these two? So the power, when you change the sign of the power, then this is equal to over 1, right? So x to the negative 2, this is equal to negative over 1. Denominator is 1. So whenever you change the sign of the power, then make it positive. So you want to make it positive, then move it to the denominator. So when you move an exponential form to the numerator, from numerator to the denominator, or from denominator to the numerator, so if you move it up and down, then change the sign of the exponent. Okay, let's try some example. Okay, here is the definition of negative exponent. So if n, the exponent n is a positive number, actually it doesn't matter, and the base is not equal to 0, this is important, then we have this formula. So x to the negative nth power, the exponent is negative, then move x to the nth power, move this one to the bottom, to the denominator, then negative n becomes positive n. Or if the denominator x to the negative nth power, so this exponent is negative, then once you move this exponential form to the numerator, then the exponent becomes positive n. Simple, isn't it? So in this case, okay, negative 7th power, this is negative 7th power, then this one goes to the denominator, so y to the 7th power. Simple. How about this one? This example, c to the negative 4th. The exponent is negative 4, so move this exponential form to the numerator. Then the exponent becomes 4, positive 4. So this is c to the 4th power. So when you simplify an exponential form, make sure the exponent is positive. Okay, so an exponential expression is in simplest form when there are no negative exponents in the expression. So if the exponent is positive, then we say it is in simplest form. But if the exponent is negative, then it's not simplified yet. Okay, so when you simplify an exponential form, make sure the exponent is positive. It does not negative. It is not negative. Alright, so let's simplify the following expression. Okay, when you simplify an exponential form, make sure the negative exponent has to be positive. So you can move this 8 to the negative 8 to the numerator. Then negative 8 becomes positive 8. So it's actually over 1, right? You just exchange these two. So that is equal to 8 to the 8th power. How about this? This one is b squared minus 9, right? So this 9, you can do a subtraction, 2 minus 9. Then this is equal to b to the negative 7, right? Negative 7. So you can move this one to the denominator because we have negative exponent. So 1 over b to the 7th power. Right. So actually you are not exchanging. Move this one to the numerator, right? Then change the sign. Even same thing, isn't it? Or can we do this way? B squared minus b to the 9th power. What happens if you move this to the denominator? So b squared moved to the denominator, then isn't it b to the negative 2, right? So 1 over b to the 9 minus 2. So 1 over b to the 7th power. Still same thing. So whenever you move an exponential form, change the sign. Change the sign of the exponent. Okay, now the definition of scientific notation. Okay, scientific notation is always written as this: 8, some number 8 times 10 to the nth power. And this number a is always between, so greater than or equal to 1, and then less than 10. So this means starting from 1.0 all the way up to what? 9.9999 and so on. So that is the value of a. So starting from 1. So the value of a is the first digit is first non-zero digit, and then decimal point. Okay, the ones digit is non-zero, and then dot and so on, decimal point. So that's a scientific notation. So okay, so if you have a number like this, 240,000, then we can write it as this. So actually the decimal point is at the end, isn't it? It's at the end. So move this decimal point to the first non-zero digit. So all the way up to here. All the way up to here. So 1, 2, 3, 4, 5. So count the number of digits, decimal point, number of places. So you are moving starting from here to 1, 2, 3, 4, 5, right? So write down 2 times 4, 2.4. So move the decimal point all the way to the right of the first non-zero number 2. And then 10 to the, so you moved 5 times, so the power will be 5. Is it 5 over negative 5? That is 5, positive 5, because 2.4, you want to multiply some number, multiply 2.4 by some number, and this some number has to be large, right? Large, because we want to make this 2.4 large number. The original number is 240,000. So 2.4 has to be, changed to the large number by multiplying a large number. So positive 5 exponent is large number. Negative 5 is smaller number. Okay, let's try more. Okay, how about 93 million? This means we have to move the decimal point We have to move the decimal point all the way after the first non-zero digit 9. So let's count how many places we move. So 1, 2, 3, 4, 5, 6, 7. So we moved 7 places, right? So 9.3 times 10 to the 7th power, not negative 7th power, because we want to make this number large. Alright, how about this example? 0.003. So the scientific notation for this is, okay, we want to move this decimal point all the way to the first non-zero number. So after this number 3, 1, 2, 3. So we're moving 3 places, right? Places to the right. So the number should be 3.0 times 10 to the, how many places did you move? 1, 2, 3, right? 3. So is it positive 3 or negative 3? This time, negative 3. Why? Because I want to make this number smaller, right? 0.003 is smaller than this number 3. So in order to make this number 3 smaller, the exponent has to be negative. So make the number smaller, then make the exponent negative. How about this number? In order to make this number large, then make the exponent positive. Okay, now let's try this example. So move this decimal point 1, 2, 3, 4, 5 right after the first non-zero number 8. So 5 places, right? So the number will be 8.32 times 10 to the, is it 5th power or negative 5th power? Negative 5th power, because we want to make this number smaller. So the exponent has to be negative. Okay, now let's change the scientific notation in standard form. So this means 3.45 times 10 to the 6th power. So this number will be large, right? Get large. So starting from the decimal point is over here. So let's move this one to the right 6 places, because the exponent is 6. So we are moving 6 places to the right or left. But since we are making this number 3.45 to make it large, because positive 6 means make it large, right? Make the number large. So move 6 places to the right. So if we move to the right, then already we have 2 places. So why don't we put 4 more zeros? So you can move the decimal point from here 6 to the right. 1, 2, 3, 4, 5, 6, right? So decimal point moved up here, and then we can put commas every 3 places from the right. Make sense? So the decimal point is here, but you don't have to put decimal. Okay, how about this? 2.3. So you are at 2.3, and then the exponent is 8. That means make the number large. So we gotta move to the right. How many? So already we have 1. So we'll put 7 more zeros. 4, 5, 6, 7 more zeros. Make sense? So let's move 8 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8. This is correct. And then get rid of this one, and then put commas every 3 from the right. Okay, then let's try the negative exponent. Okay, the scientific notation now contains negative exponent. That means make this number smaller. So make this number smaller, so move 3 places to the left. So let's put 3 zeros, and then let's move from here to the left 3 places. So this decimal point is moved up to here. So we can remove this. So it looks like this. How about the next one? Next one is 6.34, right? So let's put The exponent is negative 7, so make this number smaller. So the decimal point must move to the left. So why don't we put 7 zeros? And then move the decimal point to the left 7 places. 1, 2, 3, 4, 5, 6, 7. So the decimal point moves up here, and then remove this. So this is the number in standard form. Okay, let's do another example. Write this number in scientific notation. So the decimal point is over here, and then move it all the way to the left right after the first non-zero number 8. So that will be 8.24 times 10 to the, okay, let's count the number of places. 1, 2, 3, 4, 5, 6, 7, 8. We moved 8 places, right? So this is positive 8 or negative 8? Positive 8, because we want to make this number large. So the exponent is positive. Okay.